Well, quantum, we believe, promises the ability to solve problems that are really beyond the reach of current computers, classical computers, as we call them. We founded Zapata to accelerate the quantum technology revolution, which is, we believe, becoming the second major information processing revolution in human history. So it's a big deal. We see ourselves as really the enterprise software company that helps customers get the most value from the current state of quantum devices. Our unified quantum operating environment, Orchestra, is currently the quantum computing industry's only fully integrated quantum workflow management system. It allows users to build workflows from any quantum library, such as Cirq, Qiskit, Pikewill, or classical libraries like TensorFlow, QuantLib, QB-Solve, and then run those workflows across a full range of quantum and classical backends, and finally analyze those results. This requires us to be closely partnered with all the hardware companies and to know what the most effective software libraries are so that we can integrate them. I'd say that talent and tools are currently the biggest bottlenecks. They're really slowing the growth of the quantum technology industry as a whole, not just quantum computing, but in other areas. The community is not producing enough researchers with the expertise in quantum algorithms to meet the demand. And researchers need to be sophisticated coders as well as learned in quantum computing, which is a big ask to have both of those. And they have to know application areas. So the industry has begun providing some new tools to make creating and running quantum algorithms easier. But in reality, the systems on both the hardware and the software sides really aren't interchangeable either. So coders, quantum scientists, they're forced to learn and glue together really an ever-increasing set of languages and libraries. So solving this problem is really Zapata's main focus right now. And what we hope to contribute to that. I take a gander to say that the US has a clear lead right now in quantum computing, and I would say some areas of quantum sensing, especially in dual use technologies. I'd say that we have a lead. That's pretty clear, I believe, and that would be the general consensus. But in some areas of quantum networks and communications, it's not clear that the US is the leader. China is an emerging leader there. That's very clear. We have customers that are government-funded research labs and supercomputing centers in Europe and Asia who are investing significant resources right now in quantum computing as part of their nation's strategic initiatives. So we aspire to make Orchestra the ultimate, quantum assembly line, if you will. And today we're at the beginnings of this quantum revolution. But this is a big part of that is, using interchangeable quantum parts that we offer in these workflows. So, I want to do this and I want to do this, and these are pre-existing. How do I combine them together to make a greater product whole together? So a lot of companies have pieces of workflows that are classical that they're already doing, pre-processing of data, data that's working on simulation on that's being analyzed on HPC, high performance computing supercomputers right now. We don't want to throw all that code out and throw all those existing parts out. We want to be able to reuse them and use them better using this new tool of quantum computing as a way of leveraging them and taking advantage of this capability. The workflows themselves, they allow us to exchange, interchange, interweave these classical subroutines, the things you're already using. And this is really essential, we believe, for production-ready enterprise applications. You don't want to rip everything up and redo it again just to create a quantum capability. Especially as, an emerging company that's not a Fortune 100 company ourselves, there's strength in numbers. So it'd be one thing for us to try to, solve this as an individual company. Even large companies, one large company, one large Fortune 100 company that's making quantum computers, by itself would not be able to, engage a lot of the big machinery we need to turn around to make this all work. We're talking about, interacting with governments and getting this, solved on a policy level. And that's really hard for a small company or even a large company by itself to really affect change. And so by working with our peers in the industry, with quantum computing, quantum sensing, quantum communications across this area, we can really, and we share a lot of the same issues, we can really work together to have industrial solutions for this, but also interact with our peers in government, the government members of QED-C, and some of the national institutes to try and alleviate some of these systemic problems that really hamper our ability to grow this industry.